Hello everyone. Today I am presenting my machine learning project on water potability prediction. This project is part of my course which is data science and data analytics by PRE-GRAD, and my name is Samiksha Kadam. So the goal of this project is to predict whether the given water sample is safe for drinking or not, based on several chemical properties such as pH, hardness, solids, chloramines, and so on. Then the main objective of the project is to build an accurate classification that model determine if water is potable, means drinkable or not. So I have used two machine learning algorithms here, random forest classifier and XGBoost classifier. Okay, then I started by importing all the necessary libraries such as pandas, numpy, seaborn, matplotlib, then sklearn libraries. These libraries help me in data handling, visualization and model training. Okay. Then I loaded my data set here. You can see here. After loading, I displayed the first few lines of my first few rows of my data using df.head. Then I checked the basic details like data type, shape and missing value using df.info and ds.na. This helped me to understand overall structure of quality of the dataset. After this step, I check for the non-numeric and incorrect value in numeric column such as pH, hardness and solids. Then to identify such issue, I wrote a small function and check value that could not be converted to number. After identifying them, I replaced invalid entries with their corrected numerical forms. Okay. Then some columns had numeric data stored as string with symbols. To clean this column, I created function using regular expression to remove unwanted characters and convert them into floats. After cleaning, I confirm all the data types are numeric now. Okay. Then we handle null values here. Okay. Instead of removing them, I filled the missing values using the medium of each column and its robust method to skew data. Some columns like chloramine and organic carbons were highly skewed. To reduce skewness, I make the data more normally distributed. So I use power transformation here. Actually, I tried a log transformation here, but it's not enough. So we are using the power transformation. So this help the machine learning model to learn better and perform more accurately. Then I created a folder to save my visualization because I am doing now EDA. So to understand relationship between features, I created multiple visualization. I created cluster map to find feature grouping. I created correlation heat map. You can see here. I created correlation heat map to show how feature is related to each other. Then I created histogram here to view the distribution of numeric variable. Then I created a box plot for selected numerical features for detect outliers, and then we uh, save all the plots into the output folder, which is I have created here. Okay. Then our next step is feature and target separation. So this is. So I separated the data set into feature, which is X, and target, which is Y. Here portability is the target variable. That's why we have dropped it from the then I split the data into 80-20, means training 80% training and 20% testing data. Then we go to this scaling and balancing the data. Since the feature had the different unit, I standardized them using a standard scaler. Okay, then I apply smooth to the training data because the data set was also imbalanced, meaning the number of the portable samples was much smaller than the non-portable one. To fix, I use the smooth, and SMORE stands for synthetic minority oversampling technique, which is used to generate synthetic samples for minority class, resulting in balanced data. So I started the model training here. First I trained the random forest with the class weight which is balanced. Then I adjusted threshold to the 0.3 to decide the final prediction. After evaluation, I printed the matrix like accuracy score, confusion matrix, classification reports. Then I trained a XGBoost classifier, which is powerful and boosting algorithm. Similar to the random forest, I used threshold 0.3 here and for prediction, and evaluated the model using the same matrices, which is accuracy score, confusion matrix, and classification report. Then I use multiple metrics to compare both models. I use accuracy, precision, recall, F1 score, ROC, AUC. ROC stands for receiver operating characteristics, and PRE-GRAD, which is precision recall curve. I plotted ROC curves, and you can see precision recall curves here, and for models to visualize their performance. And finally, I save all the prediction and performance matrices to CSV file. Prediction.smooth.csv and matrix summary smooth.csv. I also exported all generated plots. I also exported all the generated plots here, heat map, ROC, PR curves, etc. into the output folder for the reporting. So in conclusion, both random forest and XGBoost perform well, but random forest gives slightly better performance in terms of AUC and F1 score. Through the proper cleaning, transformation and balancing, we improved the model's ability to detect potable water accurately. This project helped me to practice data preprocessing, feature scaling, smooth balancing, model training, and evaluation technique in complete ML workflow. Okay, thank you for listening. This was my complete end-to-end project on water potability prediction using Python and machine learning. Thank you so much.